Number 13, it asks us to identify what the solution to this quadratic tells us about the graph. So the first thing we need to do is actually find the solution. So if I take this guy off to the side, the x squared plus 4 equals 0, I'm going to just solve this for x using my square root. So I'm going to subtract the 4 from each side. That's going to give me an x squared equals a negative 4. And now from here I'm going to take the square root of each side. And when I do that, I'm trying to take the square root of a negative, so I find out that x equals, well, I can't really finish this. I say that x equals, and I just say this is no solution because I can't take the square root of a negative. And what that tells me about the graph of this thing, it tells me that it doesn't have any x-intercepts. In other words, this one is not going to cross the x-axis, so not going to cross the x-axis. It doesn't have any x-intercepts. And the fact that this thing opens up because the a value is positive tells us a lot about this graph. It means that this thing is above the x-axis and it opens up somewhere, so it never actually crosses the x-axis. That's what no solution means, because remember, solutions deal directly with the x-intercepts. Okay? In this one, it says a ball is thrown into the air from a platform that's 50 feet with an initial velocity of 64 feet per second, and I want to know what will the maximum height be. And so since it's asking me for the maximum height and it's giving me the equation of a parabola, it's really just asking for the vertex. So I need to find the vertex here and then interpret what that vertex means. Okay? So to find the vertex, I do the opposite of b over 2a. So the opposite of b, that's going to be a negative 64 over 2 times a, which is a negative 16. Now from here, that's a negative 64 over negative 32. When I divide, that gives me a positive 2. That's only half my vertex, though. That's the x value that goes with my vertex. I need to plug it back in and get the y value. So I'm going to plug that back in. So I'm going to do the negative 16 times 2 squared plus 64 times 2 plus 50. And now from here, this is going to give me a negative 16 times 4 plus 128 plus 50. And that's going to give me a negative 64 plus the 128 plus 50, which is 64 plus 50, which is 114. And so now the last thing I have to do here, I've got the vertex, I just need to interpret this. I want to know what the maximum height will be. When I look at this thing, I realize that the x value is t, that stands for time, and then this guy is h, which stands for the height. So the actual height here is the 114. So it's just the one value, and that's going to be in feet because this thing was talking about feet in seconds here. All right. So this is 114 feet, so it's just asking for the y value of the vertex this time. If I look at these next couple, it's just asking me to factor each one. So this first one, if I want to factor this thing, this is a difference of squares. X squared is a perfect square, 25 is a perfect square, and it's subtraction. Remember, difference of squares always factors into conjugate, which means one's a plus, one's a minus. And then this one's going to be an x plus 5, this one's going to be an x minus 5. Again, the factors are exactly the same except for one being positive, one being negative. And that's it, all right? That's how difference of squares factors and factors into conjugates. On the next one, I build a bridge because it's a trinomial. Anytime I have a trinomial, I build a bridge. So first coefficient times the last, that's a negative 6. So now I need two numbers that multiply together to give me a negative 6, but add together to give me this middle coefficient of 5. And the two numbers are going to be a positive 6 and a negative 1. Since I have a 1 out front on this one, it's a 1y squared, I can use my shortcut. I go right to the answers and I do a y plus 6 and a y minus 1 using that positive 6 and negative 1. And that's it, okay? So remember, when we have a 1 out front, we can use that shortcut to save ourselves some time. In the next one, I'm going to build a bridge. So I build a bridge that gives me a positive 12. I need two numbers that multiply to positive 12 but add to this positive 7. And that's going to be a positive 4 and a positive 3. Since there's a 2 out front this time, I can't use my shortcut. I need to split up this middle term. All right, so instead of having 2p squared plus 7p plus 6, instead of a 7p, I'm going to rewrite that as a 4p plus 3p, because that's the same thing as a 7p. All right, so essentially what I've done is I've gone from 3 terms to 4 terms so that now I can do factor by grouping. So I group the first 2 terms together, group the second 2 together. Out of the first 2 terms, I can factor out a 2p, which leaves me with a p plus 2. Out of the second 2 terms, I can factor out a plus 3, which leaves me with a p plus 2. And so now I have a common polynomial, this p plus 2. I see it twice, so that means my 2 factors of the p plus 2 along with the 2p plus 3, which is what I'm left with when I take those pieces away. Okay? If I look at the next one, again, I'm going to build a bridge. So in this next one, I build a bridge. That gives me a positive 15. The two numbers that multiply to 15 but add to a negative 8 looks like it's going to be a negative 5 and a negative 3. Since there's a 1 out front, it means I can use my shortcut on this one. So I can go right to the two factors. So it's going to be a z minus 5 because of the negative 5, and a z minus 3 because of the negative 3, and that's it. All right, so when I have that 1 out front, I can use that shortcut. Number 19, you might recognize right away as a difference of squares because 9 and 36 are both perfect squares. However, you always want to factor out the greatest common factor first. So in this one, I want to factor the 9 out first, which is going to leave me with an x squared minus 4 in the parentheses. And now this thing right here, the x squared minus 4, that's a difference of squares. So that can factor into conjugates. It factors into an x plus 2 and an x minus 2. And that 9 just kind of tags along for the ride. So now this is factored completely. And keep in mind, had you factored, if I think about this for a moment, had you factored it as a difference of squares first, it would have been a 3x minus 6 and a 3x plus 6. And you can notice that each of those binomials still has a 3 trapped in it. You would have had to factor a 3 out of the first one. You would have had to factor a 3 out of the second one. And so what you end up with is 3 times x minus 2 times 3 times x plus 2. So I could multiply the 3's and get a 9. So I could do it that way. You just have to make sure that you always check for greatest common factors first, and then always check for them at the end as well to make sure you didn't make any mistakes on this one. All right? In number 20, again, we have a greatest common factor here. I factor out the greatest common factor. That leaves me with an x squared plus 2x plus 3. And now inside these parentheses, I might build a bridge here. That gives me a 3. Two numbers that multiply to a 3 but add to a 2. Well, that's just not going to happen. There are no two such numbers. So what happens here is this one can't be factored any further. So in this one, the only thing I can do is factor out the greatest common factor. And that's why it's important to look for that greatest common factor first. That's the only thing we can factor here. All right, so that's it on that one. If I look at the next one, it asks me to solve. We should always check factoring first, so I have to get everything on the same side, so I subtract the 9x from each side. When I do that, I end up with a 3x squared minus 9x equals 0. And now from here, I want to try solving by factoring, so I factor this thing completely. In order to do that, I just factor out a 3x. That leaves me with an x minus 3. And now I can set each factor equal to 0, so 3x equals 0, the x minus 3 equals 0. And now I'm going to solve each of these. So that first one, I have to divide each side by the 3. So I find out that x equals 0. In the next one, I'm going to add the 3 to each side. So I find out that x equals 3. And that's it. So I find my two answers here for this particular example. It's 0 and 3. Okay? And number 22, again, the first thing I would check here is I would build a bridge. That gives me a 6. Two numbers that multiply to 6 but add to a 4. It's not going to happen, so this one can't be factored. So I either need to use completing the square or the quadratic formula. Many of us are just going to go right to the quadratic formula on this one, and that's okay. I'm going to show this one by completing the square. Just because I have a 1 out front and I have an even value here makes it a good candidate for completing the square. So here's what I do. I create space by subtracting the 6 from each side. And then from here, I do b divided by 2 and square it. And when I do that, that gives me a plus 4. Whatever I do to one side, I have to do to the other side. So now this x squared plus 4x plus 4, that's going to factor into an x plus 2 squared. Over here, I combine like terms. That gives me a negative 2. And now from here, I can take the square root of each side. When I do that, I'm left with an x plus 2 equals. Well, over here, I'm trying to take the square root of a negative, which I can't do. So right away, as soon as I see the square root of a negative, I say no solution for this one. Okay? If I look at the next one is a difference of squares, so I can factor this as a difference of squares. It's going to factor into an x plus 8 and an x minus 8. Remember, difference of squares factor into conjugates. And now I set each factor equal to 0. The x plus 8 equals 0. The x minus 8 equals 0. And now I can solve each. Here on this first one, I subtract the 8 from each side. That gives me x equals a negative 8. On the next one, I add the 8 to each side. That gives me an x equals 8. So I get two answers of x equals a negative 8 and a positive 8. And if you want to rewrite that as x equals plus or minus 8, that's an acceptable way to to denote that as well. All right. The other option there would be add to 64 and then take the square root. Just remember when you take the square root, you have to remember to do plus or minus. Okay. If I look at the next one, again, the first thing I would do is probably subtract this 3 from each side just to see if this thing can be factored. I've got x squared plus 4x minus 3 equals 0. And now I would build a bridge. And I come up with a negative 3, two numbers that multiply to negative 3 but add to a positive 4. Well, it's not going to happen. There are no two such numbers, which means this thing can't be factored. So I would probably go to completing the square on this one again. So I'm going to show you completing the square real quickly. But completing the square, this is already set up for that because the 3's on the other side. So if I bring that 3 back over and just create a little space here. Now I do b divided by 2 and square it. That's going to give me a 4. Whatever I do to one side, I have to do to the other side. Over here, this is going to factor into an x plus 2 squared. And this is a very similar situation to what we had before. Over here it equals 7. Before I couldn't continue the problem because when I took the square root of each side I got a negative. That's not going to be the case this time. So I take the square root of each side. When I do that, the root and the exponent cancel out, so I'm left with x plus 2. Over here I'm left with plus or minus the square root of 7. Again, when we take the square root of each side we have to remember to do plus or minus. And now from here I just have to subtract the 2 from each side. And I find out that x equals a negative 2 plus or minus the square root of 7, and I'm just going to leave my two answers that way. And that's what's nice about completing the square. It's actually very quick and simple once you get used to that process. All right? The next one I'm going to build a bridge. That's going to give me a negative 12. Two numbers that multiply to a negative 12 but add to a negative 1 are a negative 4 and a positive 3. Since there's a 2 out front, I can't use my shortcut on this one, so I'm going to split up the middle term into a minus 4x and a plus 3x. And now I'm just going to do factoring by grouping. So I'm going to group the first 2 together and the second 2 together. Out of the first 2 I can factor out a 2x, which leaves me with an x minus 2. Out of the second 2 I can factor out a positive 3, which leaves me with an x minus 2. So now when I look at this, I see the x minus 2's repeating. So one of my factors is the x minus 2. The other factor is the other two pieces that are left, the 2x and the plus 3. And now I can actually solve this thing. I set each factor equal to 0, and I'm going to solve each. Okay. So for this first one, I just have to add the 2 to each side. That's going to leave me with x equals 2. The second piece of this, I'm going to have to subtract the 3 from each side. That gives me a 2x equals a negative 3. And now I have to divide each side by the 2. So I find out that x equals a negative 3 halves. So I still get two answers here. I get a negative 3 halves, and I get a positive 2 for my two answers on this one. All right? But again, that one we had to factor by grouping, and then set each factor equal to 0. If I look at the next one, again, I might build a bridge and come up with a negative 10, but there are no two numbers that multiply to that and add to the 1. So for this one, completing the square is not a good option for this one because I have a 2 out front and I have an odd value for my b. So this is where I would want to use my quadratic formula, which is this guy, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I'm just going to plug in what I know. The opposite of b is going to be a negative 1 plus or minus the square root. I should take this down here a little bit. Let me try that again. I'm running out of space. So that's a negative 1 plus or minus the square root of 1 squared minus 4 times a, which is 2, times c, which is a negative 5, all over 2a, which is 2 times the 2. And now from here, it's just a matter of simplifying this thing. I've got negative 1 plus or minus the square root. That's going to be 1 plus what looks like a 40 all over 4. And now from here, that's negative 1 plus or minus the square root of 41 all over 4. And I can't do anything to simplify that thing. The 41 doesn't simplify in terms of the square root. There's nothing that there's no common factor where I can divide. So this is it. I leave my answer this way, and that's why this is a good example for quadratic formula. It stays in that format that I get when I use my quadratic formula. Okay.